Okay, we're going to begin the Chapter 8 review, the two-part review. Part 1, Question 1. We need to simplify. Look at the 18 and the 24. We need to reduce that. 18 over 24 reduces down to 4 over 3. The p and the p squared reduced to just 1 over p to the first, and the n in the numerator will not be reduced off. Number 2, in the numerator on the first part, we'll factor out a 6, and that will become a plus 2, which will cancel as we cross-reduce with the a plus 2 in the denominator over on the right. The 5 and the 10 will reduce to 1 and 2. And so all we're left with is 6 times 2 on top and 1 times 1 on the bottom. So we're just left with 12 over 1, or just 12. Number 3, we need to change this into a multiplication. We need to take the denominator and flip it and change this from division to multiplication. That'll make it easier to see what we need to reduce. The m squared and the m reduce to 1 and m to the first. The f squared and the f to the third will reduce to 1 and f to the first. So we're left with m to the first times f to the first over 5 times 1 times 1. Number 4, we need to get a common denominator since we're adding. We multiply the 4 over n by p over p, then we'll get 10 over pr plus 4p over pr, which will become 10 plus 4p over pr. Number 5, we need to find the least common multiple of 10x squared and xy squared. So we'll first look at the least common multiple of the numbers, of the coefficients, 10 and 30. The least common multiple is 30. Then we take our variables into account. We look at x's. We have x appears more than once. We'll go with the one that has the highest exponent to use as our least common multiple. And since there is also a y, we have to go with the y squared. When trying to come up with an equation that could match this graph, we look at where the asymptotes intersect, and we can use that as our that point of -1, -1, 1 would be our h and k. And so we could use the equation 1 over x minus h. So that would be x plus, or x minus a -1, x plus 1, and then plus k would be plus 1. So that's one possible equation for the graph. To get more specific than that, to see if it's this numerator is a 1, we would have to get more specific with the points on the hyperbola. equals 30x. That follows the pattern y equals kx, which is a direct variation. So number 8, suppose y varies jointly as x and z. That means y is equal to k times x times z. So if we want to set up an equation to find another set of numbers, then we would set up what k would be equal to. K, you divide both sides by x and z, then k would be y over x times z. So if we set the k's equal to each other, we have 24 over 2 times 3, and we're trying to find the other y when we know x is 1 and z is 5. So we solve this for y, simplify some of these numbers down. 2 times 3, that's 6. And 24 divided by 6 is 4. So if we rewrite this as 4 equals y over 1 times 5, which is 5. Then we multiply both sides by 5, and y has to be 20. M equal to 4 over n follows y equals k over x. Our constant is in the numerator, and n is unknown in the denominator, so that's going to be an inverse variation. So if we set up an inverse variation where y is equal to 2 when x is equal to 10, if it follows the pattern k over x, and we have 2 equal to k over 10, then when you multiply both sides by 10, you get k equal to 20. So if k is 20, and in the other situation, we have find y when x is 5, 20 times 5, so 20 times 5 is 100. I'm sorry, it's an inverse variation. K divided by x. Let's try that again. So if k is 20, and we want to know y when x is 5, then y would be 20 divided by 5, which would be 4. For number 11, we would need to get a common denominator since we're subtracting, and our common denominator would be a multiple of the two denominators. So y minus 3 over y minus 3 would be what we multiply the first fraction by. Y plus 4 over y plus 4 would be what we multiply the second fraction by. So we end up with 6 times y minus 3 over the y minus 3 times y plus 4 minus the 2 times the y plus 4 over the y minus 3 times the y plus 4, and that's equal to 3. So we can now put the two fractions together, and we get, I'm going to distribute at the same time, so I get 6y minus 18, and I'm going to distribute a negative 2y minus 2y minus 8 over the y minus 3 times the y plus 4, and that's still equal to 3. Next step, we're going to go ahead and FOIL out the denominator. simplify the numerator. So I get 4y minus 26 over y squared plus y minus 12. Which is still equal to 3. Next would be to multiply both sides, or I can cross multiply, however you want to look at it. Put 3 over 1, we can cross multiply, and we get 3 times y squared plus y minus 12 equal to the 4y minus 26, which is 3y squared plus 3y minus 36 equal to 4y minus 26. Now, since we have a squared, we need to set this equal to 0 because we're probably going to have 2 answers. So I'm going to go ahead and subtract 4y from both sides and add the 26 to both sides. So I can set it equal to 0. So on the right side I get 0. On the left side I have the 3y squared minus y minus 10. The other way to approach this problem is to look at the least common multiple of all 3 terms. So if you have a y plus 4, a y minus 3, and a 1, then if you multiply every term by the least common multiple, which is y plus 4 times y minus 3, then what happens is the first term, the y plus 4's will cancel, so you're left with 6y minus 18. In the second term, your y minus 3's will cancel, so you're left with negative 2y minus 8. And on the right side, you're left with 3 times, that flows down, y squared plus y minus 12. You distribute 3, and then you set it all equal to 0, and you end up back to this point right here, which you would then factor, and then set each factor equal to 0. And solve for the y value that makes that factor 0. Number 12, we're going to be looking at a range of values that will make this statement true. So I need 9 over m minus 5 to be less than 3. I need to know what values of m will let that happen. So first step is to look at values of m that would cause it to be undefined. M equal to 5 is the value that would cause you to divide by 0 and thus make it undefined. The next step is to pretend like it's an equation and solve for m. And that'll give me the other value that'll be a key point in determining the interval. So if I multiply both sides by m minus 5, multiplied by m minus 5 on both sides, I get 9 equal to 3m minus 15. Add 15. I get 24 equal to 3m. Divided by 3m would be 8. So the two key numbers are 8 and 5. There's 8, there's 5. I need to pick a number to test in the original inequality. I need to pick a number within each of these intervals. I need to pick a number less than 5. I need to pick a number between 5 and 8. And I need to pick another number greater than 8. So less than 5, the easiest one would be maybe 1. I'm trying to do these in my head. And then 5 to 8, let's go with 6. And then bigger than 8, we'll go with 10. So when we plug 1 into this equation, 9 over 1 minus 5, is that less than 3? Well, that's 9 over negative 4. Is that less than 3? Well, I don't know. It's a negative number, and negative numbers will be less than positive numbers. So that area is true. Let's try the middle interval. Put 6 in for m, get 9 over 6 minus 5. Is that less than 3? 6 minus 5 is 1. So is 9 divided by 1 less than 3? I don't know. Is 9 less than 3? No. That area is false. Let's go to the last interval. Greater than 8, I chose to test the number 10. So let's see if 9 over 10 minus 5 is less than 3. That's 9 over 5. Is that less than 3? 9 over 5 is 1 4/5, or 1.8. Is that less than 3? Yes. So this area is true. So the intervals that have the values of m that make this statement true would be values less than 5. So m can be less than 5, or m can be greater than 8. Those are the two areas that have values of m that make the inequality